meters. So actually it's one complete circle's circumference. That's what you can see it as. Okay. Then we also need to count this side here and this side. Okay, and then also this side here. I'm going to put double lines here because okay, this entire length is 9 meters minus 2 minus 2. That means that this is only 5 meters. So don't think that it's 3 meters. Okay, don't be confused about that. So to find out what is the parameter, okay, that will consist of 4 times of a quadrant. So depending on how you want to calculate it, okay, 1/4 of a circle, that means a quadrant, times 2 pi r, radius is 2. Okay, then you plus your respective straight line sides. So that is 5 times 2 plus 3 times 2. Okay, so you could calculate all of them together and eventually you will get about 28.566, which is 28.6 meters in 3SM. Okay, then to find out the area, okay, what will your plan be in terms of finding the area? So, Aman, can you try? How will you find the area of this? Now, what thing minus what will give you the area of the actual thing? The total rectangle minus 1 circle, right? Yes, that's what we do, right? Okay, so the area will be the entire rectangle, which is 9 meters long, and then this side here is actually 2 plus 3 plus 2. That will give us 7 meters. So 7 times 9 is the entire rectangle, minus away 1 circle, so pi r squared. So pi 2 squared. Okay, that will give us about 50.433. Okay, so when in 3SM, that's 50.4. Right? Questions? Should I even take your time to complete the homework? Unless you really complete all the homework. You completed everything. So later on, you talk. Okay, moving on to question 7. Okay. Question 7, we want to find the area of the shaded region. Okay, so Aman, can you try this again? Area of shaded region, what will your plan actually be? How will you find the area of shaded region? What should we consider? Okay. What minus what or what plus what give us this shaded region? How do we get this shaded region? What thing minus what thing can give us this? Area of the bigger triangle, right? Minus away the smaller one, right? Okay. So actually the area of the triangle will just be shaded region. So the bigger triangle will be half times base 20 meters times the height 51 minus away the area of the smaller triangle. Okay, half times 10 times 10.5. Okay, and then you just hit the calculator and you get the answer. Alright? So that's 157.5. Okay, this one do we need to round to 3SM? Should we? No, okay. Answer is exact, so it should be left as exact number. Okay. Right, then that's all. If you're done, please pass your homework to the front. Convert meter square to cm square and cm square to meter square. So in this chapter, we're going to learn meter cube to cm cube and also the vice versa. Okay? So first of all, before we go into that, we need to be familiar with different units of volume. Okay, volume is not limited to just knowing your cm cube and meter cube. Okay, we also need to know milliliters, liters, your cubic centimeters. So cubic centimeters is just another way of phrasing things. Ethan, I can hear you very loud over here. Okay, cubic centimeters is also referred to as centimeters cube lah. Okay, then cubic meters as well, we should commonly say it as meters cube. Okay, so one thing that we need to also be familiar with is about the conversion. So it is already stated in your worksheet. 1 milliliters is equals to 1 cm cube. Okay, so they are actually equivalent to each other. Okay, so you have a 500 milliliter water bottle. It is also 500 cm cube. Okay, then 1 liter is actually 1000 milliliters, right? Which is then equals to 1000 cm cube. Okay, so then the next question is, what about meter cube and cm cube? How do we do our conversion? Okay, how do we convert 1 meter cube to cm cube? If you recall how we did it for our square, or rather for our area, meter square and cm square, okay, we refer to two squares that are of the same dimension. So this time round, we also refer to two cubes that are of the same dimension. Why do I say that they are of the same dimension? 1 meter is equals to 100 cm. That one we agree on, right? So to find the volume of the cube on the left, what we will do is take 1 meter times 1 meter times 1 meter. Because this is a cube, all the dimensions are the same. So 1 meter times 1 meter times 1 meter. 1 times 1 times 1 is also 1. So the volume of this cube is 1 meter cube. But if I write it as 100 cm instead, and I do the same calculation, it will come out to become 1 million cm cube. And therefore, because these two cubes are exactly the same size, we can agree that 1 meter cube is equals to 1 million cm cube. Okay, so you may fill in that blank in your worksheet at the top, that 1 meter cube is equals to 1 million cm cube. And that is the reason. Okay. It will be equals to 5 million milliliters. do the same for part B, where we are given 80,000 cm cube. So since we already know that 1 meter cube is 1 million cm cube, but since we are trying to convert 80,000 cm cube instead, in order to get the meter cube, I will take 80,000 divided by 1 million. Okay, such that you will have 0.08 meter cube. Okay. Then to express it into liters, because 80,000 cm cube is actually 80,000 milliliters, and milliliters to liters, we know that we will divide by 1,000, okay, in order to achieve liters. So therefore, it is equals to 80 liters. Okay, may I encourage you that when you write your liter symbol, write it as such. Okay, I know some schools they write it this way. Is there anyone who write it this way? No? Okay, I know sometimes, I don't know what school teach writing like that. Okay? In computer, it is sometimes do like that. Okay, but liters I will usually write the L in such a way. Okay, so that I don't confuse myself with the number 1. As I go through my lesson. So that is our conversion of units. Okay? This thing on 3-dimensional solids, which is on chapter 13.2, okay, you will do it tomorrow on SLS. Right? So I will not be covering it today. Okay? So briefly what you will see tomorrow is about nets. Okay, whether you can recognize the different nets or not. Okay, I want to jump straight into our cubes and cuboids for its volume and surface area. Okay, so cubes and cuboids, we have encountered them before, right? Maybe them in primary school. Therefore, so not something new. Okay, so we have our cubes and cuboids over here. Right, I have this animation or this video of your cubes, how it looks like when you open it up. Okay. Okay, that's okay. Right, so when you open it up, it will look something like that. But if you cannot visualize it, I have an actual cube over here. Okay, for which you can pass it around, take a look at it. Okay. Let me just this out. Okay, so there's this cube. You can pull it out, right? It will give you a bubble. Okay. Then after that, there is also your cuboids. While it is not exactly the same cuboid as what I have on top, okay, but this is also a cuboid itself. It also opens up, okay, to a net like that. For which I have a small one here. Okay, and you can open it up like that. Right, so I'll pass it around. Okay, you slowly explore. Okay, just switch it. Okay, so what is the volume and surface area of your cubes? What do we recall from primary school? Can we recall first the volume of cube? What's the formula for volume of cube? In your diagram of your worksheet, you're given that the side is x. Okay? For cubes, all sides are actually the same. So what's the volume? It's mentioned x cube, right? because we take x times x times x. Okay? So algebraically it gives us x cubed. Okay, your length times breadth times height. Okay, then for your surface area or total surface area of a cube, okay, we look at the closed one first. What do I mean by a closed cube? It means that there are surfaces around everything. It is not open. Okay, so for example, in this cube that I have here, okay, it is actually empty. Okay, so this is what we call an open cube. Okay, if I cover it, okay, then it is considered a closed cube. Right? So in a very standard closed cube, we have how many surfaces? 6 surfaces, and they are all squares, and therefore the surface area of a closed cube will actually be 6 times x squared, or in other words 6x squared. Okay? While for an open cube, okay, that means that there are only 5 surfaces, and therefore 5 times x squared, for which we will write it as 5x squared. Yes?
I have shorten my first. I think they write V cube.
V cube. Is it V cube? No. Let's write it in full. At most you write EOL, I understand. But V cube I would understand. Okay? Not like I call you T instead of 3C, right? Okay, so then it will be very confusing because I also have 3 now. It's also W, letter T. Okay? Then when it comes to your volume of your cuboid, okay, in the diagram that I have printed for you in your worksheet, I labeled this X, Y, and H. Okay, so the logic remains the same as your cube, also length times breadth times height. What is the volume of cuboid? Sorry, volume of cuboid formula then? What do you recall? Remember, length times breadth times height and so on. Okay, so by the same formula, x times y times h, or in other words, x, y, h. Okay. But what I usually will recall is the length times breadth times height. Okay? Because all your letters over here can change according to question. Then similar, okay, to your cube. Okay, a generic idea when it comes to total surface area of a closed cuboid. Okay, how do you all learn it in primary school for total surface area? Is it you all count every single side? The area rectangle? Then times 2, front and back, then left and right, then top and bottom, right? Okay, so that's what we will do also. So in a generic sense, okay, we will write it as area of front rectangle times 2 plus area of left and right rectangle. Okay, so area of left rectangle times 2, and then area of the top and bottom. So that is essentially how we went about learning our volume of cube and cuboid as well as surface area of cube and cuboid. There is no generic idea when it comes to an open cuboid because it really depends on which side is it that is open. Okay, it can be the side left and right that is open, front and back, top and bottom. So there is no generic idea for an open cuboid. Okay, it can be open in many directions. area, there is somewhat a more straightforward way, or rather a generic formula, to go about calculating it. Okay. Let's try out these questions. Okay, I'm going to do work example 2 instead of practice now 2 from your textbook, because I find this more meaningful to teach you rather than practice now 2. Okay, so let's turn to your textbook, page 175. You may not want to write down notes since it's already printed in your textbook. Okay, maybe you can just add on certain things. Okay, so in your textbook in part I, they want you to calculate the height of the cuboid given that the volume of the cube is 378. Okay, volume of the cuboid. So therefore, we know that taking 9 times 7 times h, that gives us the volume of the cuboid, which is 378. Hence, h is equals to 378 divided by 9 divided by 7, which allows us to get 6 cm. And that's the value of h. Okay. Then in part 2, given that the cuboid is melted to form a cube of length L. Okay, I want us to take note that this question says melted. So this thing over here, if it is being melted and then made to reform another cube, what is the thing that is going to be remaining the same? The volume, okay, of the cuboid will remain the same, right? So eventually, the cube itself that is being newly made will have the same volume. And the volume of the cube is actually going to be L cube because the side is LCM. And because the volume remains the same, we can say that L cube is equals to 378. Because volume remains the same. And therefore, L is equals to cube root of 378, which you could press a calculator for. And that is 7.23. Okay. Then in part 3, it says that the cuboid again is being melted to form cubes of length 3 cm. So smaller cubes, okay, and many of such smaller cubes. So the question asks how many cubes are being obtained. So what we can do is find the volume of one cube, which is 3 times 3 times 3. That's 27 cm cubed. And because the volume maintains, okay, the number of cubes that can be formed will be 378 divided by 27, for which we will get 40 cubes. Okay, so 40 cubes are being formed. Okay. The one that I want you to pay attention to is part 4. Okay. Part 4 says, teaching said if the cuboid is cut to form cubes of length 3 cm, so this original cuboid, it is being cut now, okay, such that you can form cubes of 3 cm. Okay. And she claims that the maximum number of cubes that can be obtained will be the same as what we got in part 3. In part 3, what was being done is that the entire cuboid was being melted and then made into smaller cubes. But in this case, we are cutting it out. Will the number of cubes actually be the same? Okay, think about it. Right? Do you think the number of cubes will be the same? Okay, so if I'm going to cut out 3 cm sides over here, down here 9 cm side, that means along one side I at most, okay, I can only get 3. So I may not draw it very nicely. because 9 divided by 3. Right? So along the length, I will get 9 divided by 3. I can only cut 3 squares out. Along the graph over here, it is 7 cm. How many 3 cm can I cut out? Only 2. Okay? Because 7 over 2 is 2.5. Okay? So I can only get 2 cubes. Okay? Formed along the graph. Along the height, we have already found that h is actually 6 cm. Okay? And each cube has a height of 3. So therefore, I can form 2 cubes along the height. Okay? So along the length, if I have 3, breadth I can only have 2, height I can have 2. That means my total number of cubes that I can cut out will be 3 times 2 times 2. Okay? Because 3 along the length, 2 along the breadth, and then 2 along the height. Okay? And that will give us 12, which is not equals to 40. Okay? Because it's not equals to the answer in part 3. Right? Therefore, we say that Li Ting's answer, Li Ting's claim is not correct because it is not equal. Okay? Because by cutting method, there will be a part whereby I cannot form 3 cm cubes out. So therefore, they are not the same. Okay? Questions? Alright. Regarding this topic, I actually still have 3 more questions or a few more questions, okay, not just 3, that I want to run through. Okay? Because I find that those questions are slightly more challenging and require some interpretation, okay, I will not give that as SLS. What I will give for SLS home-based learning tomorrow will be on the topic of prisms, okay, and I will consider giving cylinders as well. Okay, more straightforward ones for you to familiarize yourself with the formula. Okay, then write down the formula in your notes in your worksheet that I've given you. Okay, yes. Oh, 6 divided by 2 is 3. Oh, that means I count wrongly. 6 divided by 3. Oh yeah, sorry, I read wrongly. 7 divided by 3. 2 and 1/3. Yeah. But my answer remains the same. Okay. So tomorrow, please look out for the SLS lesson and complete your assignment. Okay. I'll just end